Okay, so let's continue system design. In the last session, we discussed about the scalability, where whenever we design our system must be scalable. That means whenever user request or user traffic is going to increase, our system can respond. Even our data set, whatever the data we have, if our data is even going to large data set, okay, still our system is are responsive as per expected. System give the performance, whatever the request give response. That means, so we discuss our system, if our user traffic increase, load increase, we are scaling system horizontally. It's number of increase number of server, increase the number of server, increase the number of server, increase the number of server. So our some requests go to this, some requests go to this, some requests go to this, some requests go to this. So in this way, you can we can design our system that is more scalable with a horizontal scaling or vertical scaling. So similarly, we have discussed different layer of scaling. Maybe our user handling, user service layer. Similarly, we have a database layer. So now today we are going to talk, if our database going to the larger size, how we can scale our database. If our user traffic increase, so what the problem occur if, let's say, we have only one database, and if the particular table, like the particular tables, and number of records is going to increase. So after some times, you can say, if your data is so huge, our response of the database query is the going to slow, because the whatever the SQL query we are going to write, that is depend upon the number of row exist in the particular table. So some scenario you face, your database going to size is going to increase. So in this scenario, how you can ensure that our database also be responsive, we are not losing performance due to the large data set. So today we are going to talk what are the different methodologies available in which large data set in the distributed system or non-distributed system we can manage. That means our systems is still responsive as expected if our data set is going to increase. So the simple terms, how you can scale your data if your data size is very large, very large. So one database might be not sufficient in this case to responsive. If your application is small and dataset is small, is it okay? One database can handle, restore your information, and can response all the query. It's okay, it's fine. So if your applications have some larger data set, and due to the centralized data, only one data, sometime we face the performance drawback. Our query is responding slow. That means our database is not scalable. If our data size going to increase, our user request going to increase, our database also must be scalable. So what are the strategy? Today we are going to talk how we can scale our data layer. Okay, so for that, the concept known as a database sharding. Okay, so database sharding is the technique is in the system design to distribute large amount of data across the multiple server or the databases to improve the scalability, performance, and reliability. So database sorting is one of the technique where you can split or whatever the large data set you can store in the multiple server, not the only one server or not the only one database. So here you can say you can, if you think we have a large volumes of data, large volume of data, very large volume of data, so might be it is not good to fit in only one database. Maybe you can make multiple database, and now if your data, each database have a some limited set of data that need to store, they can easily store and they can easily response as well as so this technique known as a database sharding means splitting your data into the multiple server, multiple databases. In this way you can say we can scale our database as well as. While scalability, we are not losing our performance and reliability. We have to ensure that splitting your data into the multiple databases, we cannot lose our reliability. So the terms here involve means whatever your database, you have to breaking down the large database into the smaller one, a more manageable piece of data known as a shard. Shard means the smaller breaked data is a shard. So each containing the set of overall data. What do you mean? So here that means you are going to split data into the multiple database on the basis of some algorithm, some logics. Our objective is not just we have a huge large data set, a large request is coming, okay, so I'm not going to or distribute our request to the multiple database. Let's see, multiple requests come, we're not going to go to here or some requests go here, some requests go here, because objectives they are storing, and after some time I want the requests, get requests. So what happens, some data is stored here and your request come on to get here, you say data not found. So this is not the scenario happen. You ensure that where the particular customer request, customer data are stored, the same database your request also go for the get. That means which employee record, which country records are stored in which database, and if the later part get request come, select request come, your request go to the same database so that you can get the data. You cannot say, hey, no data found. What happens, you store data here but requests go to the this data here, this database say, hey, I have not such a data available for us. So while splitting the data into the multiple database, we have to apply some algorithm so that whenever next time get requests come, your requests go to the proper database. Due to that, we are going to discuss multiple algorithms available which solve this problem to splitting our data into the multiple database, so that you can ensure that later the requests come to, hey, I want to get data, I want to fetch data, so your requests go to the proper database. So database sorting is a technique where we are designing our system that handle large amount of data. How to handle the large amount of data? We are distributing across the multiple database server. The objective is that you have a large data set, large number of requests. You are not going to landing in only one database, but in the case of multiple set of database 1, 2, 3, 4, 5. So we are going to discuss what the algorithm, what the techniques we have to sort our data. We have to break our large database into the smaller one. Okay. So question before going to understand techniques, again here, whenever why we need to database sharding, as we discuss, first things, manage the large data set. When we have a huge large data set, one database table is not manage this large data base volume of size. So one database is not sufficient, one way. Second use, when the our user traffic is going to increase, only one database is also not serve all the requests from the one database server. So two scenario where you need to think database is going to need to shard. One, to manage, to store the large database, large data set. Second, whenever your system get request, user traffic is going to huge, so that one database is not responsible sufficiently. In this case, you are going to use the multiple database, so that your user traffic can be diverted, some set here, some request here, some request here, so that you can distribute your user traffic load to the multiple database. While distributing your load, yeah, managing, splitting your complete data set from the multiple databases, we have to ensure that our applications should be scalable, improve the performance, and maintain the availability. So if you are going to apply database sharding, which by default you get your database become a scalable, improve the performance, and become a high availability. What do you mean high availability? We'll discuss. Means now each request come, if your multiple database instance available, you can serve. So we are going to discuss, if we are apply database sharding, our designs become scalable, improve the performance, and your database is available to serve when user traffic going to increase. So here good example about the scalability. So whenever you are designing our database layer, that must be scaled, that means the volume of data grows, single database become a bottleneck, leading the performance issue. So if you have only one database, for some days, for some user requests, some user traffic, it's work fine for thousands of requests, 10,000 requests. But whenever go millions of requests, billions of requests in a day, per minute, per second, so one database is not sufficient to respond every request as per the expected demand. Due to that, we are going to apply technique sharding. Sharding allow us to scale our data horizontally to adding more shard as needed. Shard means logically break the data. So now instead of only one database, you are horizontally going to add more server, more database server. All data have some logical content data. We are going to discuss how to start breaking the data. But now, if now our system are capable to handling millions of user requests, some requests go to the here, some requests go to the here, some requests go to the here, some requests go to the here. So logically, load balancer is going to distribute our load across the multiple database. So in this way, if our volume of data going to grow, you want your database is managed, handle the scalability issue, that means you have to use the sharding. That means scale your data base, means that means increasing the number of more shards, or shard means logically database. So scalability is solve our problem when the volume of data grows or user traffic is going to increase more and more. So now single database is not become a bottleneck for you, because now you are storing data in the more database server. Whenever you are going to store data, distributing data source across the multiple server, so what the benefit you get? You can reduce the load on individual server and resulting a fast query execution and improve the overall responsive. Now our user requests come, huge requests come, you are not just letting them only one server to respond for every request. Instead you are redirecting to the different server. One server here request go, one server here request go. So now your database is now scale horizontally. Now each database are responsive as fast because they have a very limited logically related database. They can quickly get requests and quickly respond. So in this way, if you are scaling your database, your application performance is going to improve, right? So one database is also good, multiple database is also good, depend upon your data volumes. If your user requests or data volume grows, one database server is not sufficient, then you are going to make a multiple database, and in this way at least you can scaling your data, still you maintain your system performance, your responsiveness. And also third benefit you get if you are scaling your data, that means database is horizontally you scale, multiple data center database you can create it. So what happened, one sort become unavailable, another sorts continue to operate and ensure that system remain available for the user. So what happened if the multiple database available, if one database somehow going to back up or restore or down, at least our other request applications are served by the another database. So somehow you can ensure that if your database is scalable, then you can make your system at least available for other users. Let's see, some user can be not able to access our webinar, but other users are still able to get data from the other databases. So somehow say ki our system is available for others user as well. As you cannot say if let's say only one database and one database somehow data center going to down, your whole lots of user requests going to stop because you are not able to serve any kind of data. So this is the very single point of failure, single bottleneck. If you have only one database and our user traffic is so high, so is it not possible only one database can serve the every request. So you as a database designer, you have to ensure that our database have a multiples copy and multiple places available, so that if one data center, one database is going down, still other database is able to operate and response to the user. So in this way our database sharding or scaling data also ensure that our system is available. So these kind of benefits we get database sharding, while your system design is scalable, your system is highly available, and your data is improve the performance if you are applying database sharding designs. Okay, so I'm talking what are the different way how you are going to shard your databases. So there are a couple of way where we are going to discuss to database sharding. So one way horizontal sharding, another way vertical sharding, another way hash based sharding, another way directory based sharding, another way consistent hashing. So here horizontal sharding also known as range based and some column based. So what do you mean here? Already we discussed sharding means now you are going to decide I am going to use the multiple databases. Okay, so question is that you have to think how you ensuring which data, which customer data are going to store this database, which data are going to store here, which data are going to store here, so that in particular user request come, the user request also go to the same database where his data is stored. If another user come, you go to the this database. So this logically mapping, you have to ensure whatever user requests come from the user request, you have to decide this request go to the SARD1, SARD2, SARD3, SARD4, whatever number of SARD. So here we are going to learn couple of techniques, the way you can decide which data are going to store in which sharding. So the user request come, from user request, our load balancer, our applications logics can decide I am going to route this user request to the SARD1 or SARD2, SARD3, SARD4. So these couple of algorithm techniques available which help us to break your database in the different SARD. So let's talk one by one. First, range based sorting. What do you mean the range based sorting? Let's assume we have our user base. Let's user base from, we have a millions of users. So from maybe you can say 1 to 1000 maybe contain one database. Maybe employee ID from 1000 to 2000 in this database. Employee ID 3000 to 4000 this database. In this way, multiple SARD you created on the basis of employee ID. This is the one range base, means you say from ID employee ID 1 to 1000 data are available in this SARD1. Okay, SARD2, SARD3, SARD4. You can say from 1001 to 2000 you can SARD2. Similarly 2001 to 2000, 3001 to 4000. So in this way, logically you say, hey, this my database design on the basis of range from 1 to 1000 requests is served by the SARD1. So any user request come and you find the employee ID is the 100, 200, this request go to the SARD1. Or maybe another request come that from the 4000, this 4000 IDs come under our SARD5. So you can say whatever the user request come from user ID, you identify, hey, this request go to the particular SARD. This is a range based sorting. Means maybe you can understand date, maybe every month, from January month you can store here, February month here, March month here, May month here, for each month wise or each range of date wise, maybe each year wise, you can say each quarter wise, for quarter 1, quarter 2, quarter 3, quarter 4. So in this way, logically you decide, hey, the particular maybe customer data, birth, the transaction data in this way. Or even you can say location wise, hey, this A location, this is the B location, C location, D, region wise, location wise, date wise, you decide and you can distribute. So generally here this kind of sorting, range based sorting is divide data into the sort based on the range of value for a specific column, maybe your date, maybe your employee ID, maybe location. So generally this kind of scaling, horizontal scaling, range based scaling, you can say any social media platform sort its data using the user geographical location. So generally all the nowadays social media platform, they are sorting his data on the basis of user geographical location, from which location user belong. If user belong to the United States, so one data just handling the United States data, one sort for European, one sort European, one sort for another region, one sort for another region. So region wise, across the globe, region wise they can create a database. So in okay, user request come from the US location. Let's go here. User request from the this is region. Go to the here. So in this way, you can say range based sorting. You are distributing user request across the different data center. Okay. So let's talk another form of algorithms. So that is known as a column based or vertical sorting. So dividing data into the sort based on the subset of column for each table. Instead of you are storing every information in a particular row, why not store some set of data? For example, here let's e-commerce platform sort its product data by separating product information, somehow name and descriptions are abcd storing in the separate database, particular pricing, inventory detail in the separate database. So here group of set of columns, not just only one column. So here decides the name, age and descriptions would be the separate table, and corresponding details, pricing in the separate database and separate database. So generally all the e-commerce platforms using these techniques, they are sorting our data on the basis of set of columns, not the only one column or two column, set of column for each. So in this way you can say कि multiples are database are divided on the basis of set of column value. So this is another column based sorting or vertical sorting. Also is the hash based sorting. So hash based sorting also one of the technique used, dividing data into the sort using the hash function. What is the hash function? Hash function is simple hash function. You pass x input, you pass x as an input here, x as my input, they return y as a output. This is a hash function. So always if you pass x, they always return a u. This is known as a hash function. So you can decide your hash function and you can just use it. So generally all the web applications use the sort its user session data using the hash function and distributed session across the multiple server. So according to the sessions, number of users, which this number of session go to the this data, this session, this data. Generally hash functions is very, you can say, common algorithm approach where you are distributing your load to the different database. Let's you have a 4 database server you have decided, so your hash function ensuring the particular hash, according to hash function you apply and they go to this data or this data or this database or this database. So hash functions is the one of the technique, the way whatever the user requests come, apply hashing on the basis of your number of server, and hash function generate some logical number, and from logical number that you can decide it will go to the here or here or here or here. So in this way we can generally use sometimes all the web applications generally use such type of hash based sorting. And similarly many applications also use the different approach to directory based sorting. That means sort mapping information in separate directory or lookup table. So somehow they create one directory system or lookup table. Okay, this user informations are stored in the specific database. Oh, go here. User request this is go to the this database. This database detail go to the this database. So from they have create some kind of lookup table. First go to the lookup your dictionary table, lookup table, and find out corresponding where data is stored. Just redirected to their request to the particular database. So generally in such kind of sorting used by the your content delivery networks, use this the directory based sorting approach to map user requests and cache based on the geographical location. The geographical location accordingly they can create the separate data stores. This is the lookup table is also many place used to for the different purpose. Just First request go to look the lookup table and find out this request are for which database we already mapped. Go request directed to the respective data center. And sometime we also apply the your consistence hashing. These you can say on the top of your hash function. So last we discussed, whenever we have function, let's this is our hash function, and you pass your x as an input and we returns y. So generally hash function here, function could be, let's give whatever the request come, maybe request id 1000 id request come, you apply hash function. So hash function generally depend upon the number of server. Let's give number of server 1, number of server 2, number of server 3, number of server 4. So you can just say, hey, a simple way, whatever the request id come, just modulo 10, modulo number of your number of shard, like 4, just say you can say 4. So you can just modulo, and whatever the number they returns, modulo you can store and return. So always modulo 4 always return maybe your 1, 2, 3 or 4, whatever the value. So according to, you can each request, if request come the 200 or request 500, you can just modulo 4 and go to the corresponding server. So in this way your hash function works. The hash function works very fine. Always distribute your load across the different server. If user requests come according to the go to load. But the only challenge is with the hash function, if we can increase more server, you can increase more server, then your hashing function we have to change. Now our server number of server, instead of 4 you can increase 6. You have to again rehash every request, because when now your hashing function change from the number of server 4 to number of server 6. So this is the normal if you are using hashing function, where you face such problem. If our database server load going to increase and you are going to increase more shard, or maybe one database shard is going to some network issue or fault or down, then our hash function we have to change, because our hash function is depend on your number of server. If your number of server going to decrease, still we have to rehash, or your number of server going to increase, you have to apply rehashing. The rehashing takes some times. So this is the problem with the hash function technique, where data going to distribute across the multiple shard. So the solution comes from the consistent hashing. The consistent hashing ensure that even our number of shard going to decrease or increase, some failover happen, you are going to add more server, is still you are able to manage limited rehashing, not rehash every request. So some basic level of some range base, you can say hash value change and others are not changed. So hashing, consistent hashing somehow apply the ring algorithms, where say, hey, we are dividing every server on a particular ring level. If particular server going to increase, decrease, only one portions, to the next request, these two servers requests are going to rehash, and every hash are not going to the change. So this is the, you can use hash function map row into the shard in a minimized number of rows that need to be remapped if the number of shards change. So as consistent hash mapping reduce your rehashing. So instead of you have a 10 server, if you are using the hash function and any change, any number of shard going to decrease or increase, you have to again rehash every data center. So consistent hash mapping say we are going to reduce those changes, and only one portion, only one segments or one or two labels rehashing required, else everything without change. So generally distributed caching system use the consistent hashing, ensure that cache entry are mapped the correct node, and after even some nodes removed or added. So consistent hashing mapping is one of the key feature even your server failure happen or load increase, you are adding more shard, is still they provide the minimum changes. Not the, you cannot say कि consistent hashing or completely avoid the rehashing. No, minimum number of rows, minimum number of rehashing required. But in the case of hash function, all the shard need to be rehashed. This is the problem with the hash base. But consistent hashing, you can say on the top of your hash function, we have different technique applied to ensure that the ring based algorithms where all the shards, all the nodes are in the ring base, and a particular if one node downs, next node, his all the requests is taken care by the next node. So this is the one node or two node consistent hashing change, rest is works as per expected. So these are the consistent hashing, or hashing is a very big topic. You can say we have to talk detailed in discussion in coding wise, how we can map this hash function, how we write, whatever the programming language you can do. But yes, nowadays these are the different approach, the way you can decide while distributing your database or shard or nodes. So let's talk these database shardings, what are the normal commonly used. So whenever you are designing any large scale application like a global e-commerce platform, means you have a e-commerce platform like Amazon's, they are available globally across the globe, all the whole globes, everyone try to access your product, view product, order product. So large scales of e-commerce applications generally use the database sharding. And even I discussed all the social media, because social media, whatever the social media I have to develop, might be Twitter, might be LinkedIn, Facebook, Instagram, they are used by across the whole world, across the different geographical location, different time zones. So only one single database is very hard to manage such large requests. So in this scenario also we are going to use the database sharding techniques. Even all the real time analytics, whatever the real time analytics, like in the case of maybe financial institution, stock market, where you are provide the real time analytics and the only one data, if you receive everything, this is very hard to give the proper response for the large data set. So sharded data, regional base, geographical location base, you can provide customer near real time as fast as data to the customer. Similarly, all the CDN related application like Instagram, or all the web applications, mobile applications where they are using the CDN content delivery networks, these are also using to distribute the user request on the different node on the basis of your database sharding techniques. Similarly, your IoT device, that means your sensor data, weather data, which are continuously generating data. A continuously generating data is not feasible to store in one big database. So all the IoT data processing's outcome we are storing in the generally time series data or sharded data in the multiple database. On the here IoT data generally maybe monthly basis, maybe yearly basis, quarterly basis, depend upon the times range basis or different algorithm, whatever things we are going to store. So you can say ki all these applications, whatever you talk domains, all they are continuous base generating data, or continuous base anytime 24/7, anyone can access your applications, where user traffic is very high and background data also manage the large data set. So two kind of, if your systems are designed to handle large traffics and store millions and millions of data, so you must design your system, backend system, database system, use the database sharding techniques and split data into the multiple server, horizontally store your application so that you can meet these use cases. Okay, and these are the good part, but while splitting data into the smaller part, scaling data in the different sub databases, there are some challenges we cannot forget. We have to keep in mind, because finally you are treating the data. If you are diverting data and they are lose some customers say, I'm not found any data, even my profile exists, you are going to very big trouble. So while all the good part about the database sharding techniques, that's good, but you not keep missing the what the challenges, what the disadvantage, what the point you have to keep before applying these techniques. You must know if something happen, we know these are the challenges. So one is your hot spotting. What do you mean? Occur when single shard become overloaded and causing performance issue. अगर let's you decided कि multiple database and somehow still all the requests go to the only one, or majorly requests go to only one database, still you face challenges. You have to ensure that whatever the number of shard you decided, your load is distributed across the different shards. No make any benefits. You decided dozens of shards, but your requests only go to the couple of one or two server. Still you are in the same problem where without sharding. So sharding techniques, technology, sharding algorithms you are using, please choose, be carefully. Let's you divided location based. You notice USA and compare to the India. So same kind of one server you apply. India, China have a huge number of populations. So the request is served by one database might be not possible for the India location or China location. Might be possible for Australia, might be possible for London, might be possible for Spain, smaller countries. So please be carefully to think, observe your shard. Requests are distributed among the different server as possible. Similarly, second issue I have to data inconsistency. When data not properly replicated across all the shards. What do you mean? That means one request come, go to the server one, okay, you say you request. Next time your algorithm say maybe time-based routing, some different routing, and this request go to the another shard, some anyhow. So here say your data not found. User is very frustrated. Hey, one request you are serving my data. After second request you are saying, hey, no data found for this user. So this kind of data inconsistency. Sometime we have to ensure that every request is served data. If data exists, you have to tell. Because from user perspective, user don't know you are store his data in the multiple database, multiple location, multiple table. He doesn't make any user point where they request and they are expecting data. You never say, hey, first request come, you are responding data. Next request come, you are responding data. Third request go, you can say, oh, your data is not found. Why you are maybe your request is routed to the different database and different database say no data found. So some things ensure that not happen. Data inconsistency must be taken care before you designing splitting your data. Even you increase the complexity, means ki sharding can add complexity to the system, making it hard to manage and maintain. Reason? Because only one database is easy to maintain, but you have a maybe 10 number of database. Okay, so 10 database you have to need properly update, properly recovery, properly backup, properly restore. Everything you have to maintain. If any database down somehow, how to recover them, how to replicate them, what happened this particular location server down, you have to make another server available for it, is or not. So if you are going to scale your database in the multiple servers, multiple database, you have to ensure that you have to make some resilient solution to maintain those, manage the all the sub databases. So these are the increase more complexity from the administrative side, and also sometimes query complexity. More complex query, additional logic to handle the sharding scheme. So now let's, before we have only one database, multiple tables we have. Here one request come, and one request, hey, this is joining from this table to this table to this, and get proper data return here. Might be case this data in the different database, this data in the different database, this data in the different database. What happened? This is the one of the major problem. If your data is stored in the multiple database, the joining part, we know the relational concept between the data, these are make more complexity. You have to be ready to design some service layer logic in this such a way so that you are going to get data from the multiple database charts and populate the business logic, and then return the data. So might be you have to put some extra business logics where you are going to read, for some customer you are going to read from the data from the multiple chart, and then you have to put the business logic. So your complex query designs we have to rethink again. You cannot think just this is only one database, I can apply all level of query and easily data we can get. No, because now one data in the different data center, one data in the different data center, so you cannot apply any kind of joining, any kind of query. So complex query handling in the sharded database system is very tough challenges. And similarly your data migration. So whenever you are you can also challenge even the sharding requiring the carefully planning to execution and avoid the data loss and the corruption, because you are going to store data in the multiple database. Okay, and if what happen, this data crash, loss, you ensure that the whatever the data is stored here, they cannot lost. Somehow you have to some mechanisms to restore those data, because customer data is a very important. The database, let's keep, you are created your user profile on the Facebook. So this profile data is preserved for years and years. Whatever the database technique you are using, you are moving the one location to another location, but let's see after 5 years you say, hey, your user profile data is deleted, you can again create your user profile. No, you ensure that if you are splitting data, because if you have only one server, you are using a very powerful machine that cannot be so easily lost the data. But if you are using the scaling more instance, your server database server is not so powerful, not so expensive, so chances is that your database can be crashed, can be lost. So in those situations, you cannot say, hey, my server is down, my database is crashed, I cannot recover your data. This is not possible. So this is the one of the major problem with the sharding. So whenever you are splitting data into the multiple region, if some database server going to down, crash, you have to add some more technique to ensure that this data is still available for the users. So this is the overcome we talk near about next. Replica, you have to put whatever the data here available, somehow duplicate copy available some different region. If this region is destroyed somehow, you know this is the duplicate copy available here, I can return customer from this replication. So we are going to, so in the case of sharding environment, you are distributing the multiple database. Another concept come in the design is the duplicate copy. The number of duplicate copy, not the only one copy. So generally replica, database replica. So all the shards you are going to make a replica, make a duplicate copy of, maybe this is the one data, maybe I'm going to put the 3 copy of whole data in the 3 different region. so that one somehow region earthquake happens, some region destroy something, you still have a 2 copy of extra backup copy. So this concept known as a database replica. We will going to talk in the next session how, what the way, what the meaning of data replica, what are the different techniques available to data replication. So these are the some challenges we face while designing system at the database sharding level. Okay, still lots of challenges, but still industries are using database sharding because they have some different techniques available to overcome those challenges. Nowadays, all the big players where they are managing large scale data like Amazon's using database sharding techniques. So range based sharding for the e-commerce application like Amazon application use this range based sharding. Still this advantage, they have an alternative available how to handle those situations. The extra work required, but the way the extra work required, we are managing huge database, huge application, so still manageable, you can say. So Amazon using the horizontal sharding. Similarly, talk about Facebook. Facebook also is your vertical sharding, column based sharding. So column based sharding, it's a database in social network platform, generally Facebook use. And if you talk about the Google also use hash based sharding for his search engine. Whatever the keyword you are searching, they just calculate your particular hash and diverted your particular request to the particular server. Even Microsoft also use dictionary based sharding for the Azure cloud platforms. Even Netflix, you talk, they are using the consistent hashing algorithm for the database for sharding its database to streaming videos. So you can say all the big players in the IT industries are using database sharding techniques. This is a couple of, I'm just limited example I said, which currently nowadays in the industries are using this database sharding technique, because now these are the very big player. They are handling millions of requests daily basis. Whenever your system you are designing that can serve millions of requests per minute, per second, it is not possible one database can manage and serve every request. So surely you are going to scale. Surely vertical scaling might be not feasible here. You can go the horizontal scaling, means adding more server, maybe 10 server, 100 server, 1000 database server we are going to store to serve the millions of requests. So this known as a database sharding, because you are going to put data logically. That's not matter just split and put somewhere, because if you are putting data, you need a get as well as. So due to that, we need some technique. Whenever you are splitting multiple, you know the from finally request come, you redirect to a specific server so that you can get again the response to the customer. The objective here both is splitting in the multiple database, it's one way, and also we have to think later part, if customer requests them, we have to redirect customer request to a specific database server so that the customer request can found the data. So these are the very key concept in the system design, because whatever the system you are designing, system must be, you can say, scalable. That means nowadays whatever the system you are designing, you don't know the number of requests served by my application. Might be, let's say, the Facebook or Instagram or LinkedIn, they are not know exactly how many number of per day user going to request, maybe 1, maybe 100, maybe millions. So such global application, you can say, whatever the database you have, that must be going to the use the database sharding techniques. If your application, you are designing application, that's are very specific use cases, You know, these are the limited data center. You are designing one application for a specific company. This company, I know this company have a 10,000 employee or maximum 20,000 employee. One database is this can serve. All the data can request, all the data can get. One database is good. So the database sharding is not, you can say, every design you are going to apply database sharding. No. Let's think for whom you are designing this system. How many number of user base? What are the volumes of data you have? Accordingly, you have to scale your database. Else, one database is sufficient to serve your limited number of use cases. So in reality, many of applications that not require database sharding, because all the applications we are building, that's not for global. Generally nowadays you are building for a specific domain, a specific organization, a specific location, a specific country, a specific company. A specific company also have a specific range of data. You are designing application for only for the HR, yeah, only for the CEO, only for the worker. So you know this, the volumes of data maximum you can get. So mostly applications are not required database sharding. So every design you cannot blindly put database sharding techniques. If you think you are designing application for a globally, that application serve 24 multiplied by 7 across the region, across the world, that's the possibility. You must design your database must be scalable. So what the key point? Key point, you should know the database scalability concept, database sharding, different kind of strategy. But blindly you cannot apply database sharding in every design practice, every designing your system. While designing system, please keep the use of your users. Whatever the for customer you are designing system, let's look the data size, user traffics, data volume, and then you decide. And this is my personal experience. Many places, you can say more than 70 to 80% application you are going to work where your database sharding might be not required. Only 42, you can say 40 or 30% applications where you are going to the build globally, so where database sharding is required. But somewhere, if you think your application going to serve years or years, 1 year, 2 year, 10 year, 15 year, 20 year, and after that your volume is going to increase, then keep in mind your database must be scalable. If you are building application that comes serve last 20 year, whatever the data range 2J have, let's multiply by the 20 year, and you think this one database is sufficient or not. If not sufficient, let's go think you must design system for the database scalability. So database scalability is depend upon your volume of data. So this is the basic designs ethic you have. Whenever you are going to design database and you have to design database, first calculate the data volume size. Volume size for 1 year, 2 year, 10 year, 20 year, 50 year. Ask customer how long you can going to serve this application, and in last 50 year the volume is generated by your application, your customer is under manageable one database, it's okay. If think no, after 10 year it's not manageable by one database, your system must be support your database scalability, means multiple database you need to again use them. So database sharding or data scalability is after you calculating the data volume, your capacity, whatever the data is stored, the number of bytes, number of GB, terabyte data you are going to serve, process and store in coming 1 year, 5 year, 10 year, 15 year, 20 year, 30 year, 50 year. And once your calculation done, then you can decide here we have to maintain. So any application you are going to support larger than the 5-year, 10-year, generally they required database sharding, database, multiple database. So many places you find, but some small mobile applications, something very silly applications might be not required. But any enterprise applications where your application going to serve couple of years, first system designer of practice, talk to the customer, calculate data size for 1 month, for 1 year, for 2 year, 5 year, 10 year down, and average data. So let's key one user, one profile, you are going to manage 1 MB. So let's set number of profile, number of day, number of year, calculate the size. And you know, nowadays all the database have a pre benchmark available, how many number of data they can serve. Let's compare and decide. So database scaling is also one of the critical concept in the system designs, and database sharding is one of them. Let's explore. Thank you for watching.